Hello everyone, good morning, good afternoon and good evening. My name is Vishwadeep and I welcome you all on PW Gatewala channel. Today we are going to have the second lecture of process scheduling algorithms. Yesterday when we started process scheduling, then we have learned two types of algorithms. One FCFS, second SJF. In these two algorithms we have seen when a process scenario is given, how to execute them as per the algorithm plan, whether it is FCFS or SJF. Based on that, we have seen how to prepare a Gantt chart. Then after that, we have learned how to calculate the completion time, turnaround time and waiting time, then average waiting time, then average turnaround time. Many things we have seen. So what exactly the specialities means, advantage and disadvantages are there, we have seen yesterday for FCFS, and what are the advantages disadvantages we have for SJF, that also we have seen. Some confusion is there, not exactly confusion, two different types of people are there. One who believe that starvation happens in FCFS, other who believe that starvation does not happen in the FCFS. So in FCFS, as per the previous year GATE question, we will go ahead with one type of conversation that FCFS does not suffer from starvation, just because process will get the CPU once the first process completes. So whenever in whichever order processes are coming, they will execute without having indefinite wait. So this is what we have seen yesterday. Today we are going to cover the algorithm SRTF. What is the meaning of SRTF? Shortest remaining time first. See, very simple it is that when we have algorithm SJF, the biggest problem with SJF is not having preemption option. I'll give you a very simple example and you will understand it with that example beautifully. How many of you have ever played cricket on ground with your friends, or with your colony mates, or building mates, or maybe neighbors, with your school friends? Have you played cricket in the ground? I'll this example I have taken from my childhood when we used to play to ground the cricket game on the ground, which was around 1.5 to 2 kilometer from my house. So it was, their house was there at the uh, other corner, ground was there other corner, entire team was living in different area. We used to go by bicycle, or by walk only to the ground. Now what if 7 a.m. is the start time? Every player was not reaching to the ground at 7 a.m. Only few members along with me used to reach. So let's assume you and one of your friend have reached to the ground. You have opponent team entirely ready, but your team member all are lazy people. They don't reach to the ground at all. So you and your friend, only two members from your team, remaining all are just on the way. In my era, there was no any mobile phone, no any telephone, etc. Nothing was there. We do not have idea that when the people will reach, when the players will reach, if this fellow will definitely come to the ground or not, we don't even know. So we were just having the waiting game. Opponent team entire is present over here, so they are asking, let's have the toss. I am the captain, I am doing the toss. We won the toss, we started batting. So me and along with me, one more guy started playing. I know the other fellow who has reached to the ground is that fellow who usually don't get the chance to bat. See, it's like 8-10 over match. In that 10 players will, play. Definitely every player will not get the batting, proper batting. If every player will not get the batting, then what happens? What happens? Only the best players who are playing better, who can play better, score more runs, will play more balls. This fellow know that. that I won't get batting if I will not reach early. So he has reached early and he is now playing with me. Opponent team is forcing, no, match is started at 7. We will start at 7. You and along with you, this fellow will start batting. This fellow is not the best player of my team, but started playing. Let's assume we started playing. He has played 2-3 balls. I have played 2-3 balls. 1 over is over. And after 1 over, one player is coming to the ground. And that particular player is far, far better than the other friend who has reached along with you at 7 a.m. You tell me now. You tell me your friend playing with you, another player comes after 1 over. That player is better, but rule is you cannot retire this fellow. This fellow will get out, then only other fellow will come out for batting, otherwise not. And this fellow is not getting out. Why? Just because this fellow is like this only, doesn't make runs and does not get out. He does not make runs, he does not get out. I am stuck. I can't make my better player play. After retiring him, later on you can bat, boss, but he is not agreeing. Problem? Yes. This is what happens in SJF. If a particular process arrives first, that is a larger process. If that has been scheduled first, then the other process we cannot schedule, which is coming later and smaller one. So the bigger process cannot be preempted, cannot be forcefully stopped by checking out that, okay, later on a better process has come, smaller process has come, but this process is already executing. Now in SJF non-preemptive algorithm, you cannot stop it. And that problem we can solve here SRTF. This problem we can solve here SRTF. So SRTF is nothing but the preemptive version of SJF. So criteria is exactly same. What is the scheduling criteria? The process with the smallest burst time first. But if two processes are having equal burst time, then we need to go for tiebreaker. Tiebreaker will be equal to what? Tiebreaker is FCFS. The process which arrives first should be scheduled first. And the type of algorithm, nature of the algorithm is preemptive. So if later on a new process comes that is a smaller process, then the current running process can be stopped even without completing. This process completed somewhat, its remaining time is larger, new process comes and new process is smaller. Stop the execution of current process and schedule this new process just because new process is even smaller. And that is what exactly gonna happen. Okay, let me give you a simple example. With this particular example, look at this. I will draw the Gantt chart. So I will do one thing. I will draw the Gantt chart for SJF first so that you can understand the difference. At time 0, when we have first process arrived, yes, only P1 has arrived. P2 will arrive at 1, P3 will arrive at 2, and these two processes are smaller than the first process P1. But still, tell me, at time 0, we do not have any other process. P2 will arrive in future, P3 will arrive in future, P1 is still available, only bigger, but only available. We will have to run which process first? P1. So P1 will run. At one time, this process which is smaller will arrive, but I cannot stop P1 now. Already given for execution? Yes. So P1 will run for 4 time duration. Completed. Till 4 time duration, P2 and P3 will arrive. Yes. So what happens? One after another, both will run. First, smaller process I'll have to run, which is P3 for 1 time duration till 5, and then P2 till 2 time duration till 7. This is SJF. Further, now we will understand SRTF, shortest remaining time first. I will give you easiest possible way to practice this type of question. Look at this. At time 0, what all processes arrived? Only one process arrived, which is P1. So I will schedule P1. Remember, the scheduled process will run till two conditions. Either till P1 completes, then only P1 will leave the CPU, or if other process arrives, when a next process is arriving, I'll have to run P1 till either P1 completes fully or a next process arrives. Whichever comes first, do that. So P1 will complete till 4, but next process after P1, P2 is arriving at 1. P2 is arriving at 1. P2 is arriving at 1. Okay, the name here is not correct. Shortest remaining time first it should be. It's okay, doesn't matter. So P2 is arriving at 1. If P2 is arriving at 1, I will run P1 till 1 time unit, and then I will run my scheduling algorithm and check that at time unit 1, should I continue P1 or should I preempt P1 and run the next arrived process P2? Should I stop P1 and run P2, or should I continue P1 only? That depends on the remaining time of P1 and remaining time of P2. What is remaining time? What is remaining time? Boss, already given in process scenario that to execute completely P1, it will need 4 time unit of execution. If it will need 4 time of execution, I have already executed 1. If you will need 4 chapatis to fulfill your stomach, you have already eaten 1. Remaining how many you will need is just 3. So I'll have to update remaining time of P1. P1 already executed for 1 unit of time. Remaining time is 3. Now I will compare current running process. P1 remaining time is 3. Newly arrived process at 1. P2 remaining time is 2. Which process I should run? The smaller process. Comparison, I will do smaller process is P2. I will execute P2. P1 is preempted here. P1 is preempted here. Are you getting this point? Are you getting this point? P1 is preempted here and P2 is executed. Or P2 is given CPU. Now if P2 is given CPU, I will run P2 till either P2 completes for two time duration, or if before that next process arrives, then till that time. So if I'll run P2 completely, 1 plus 2 till 3 I will run. But before 3, P3 arrives. Before 3, P3 arrives. So P3 arrives at 2 only. I will run P2 till 2. 1 to 2. 1 to 2. For 1 duration, I have run P2. Its remaining time is 1. Now, at time 2, P3 arrived. Yes. Now, comparison is between this process which is currently running and the process which is next coming, P3. What is the remaining time of P2? 1. What is the remaining time of P3? 1. Which one is a smaller process? Both are equal. Both are having equal burst time. If equal burst time, then which process should I execute? What is the tiebreaker, boss? FCFS. Whichever process comes first. Arrival time of P2 is lesser. So let's continue P2 only. We are not preempting P2, but we will continue P2 and execute it fully. Done. P2 finish. Done. Then P3 was waiting. Yes, P1 was waiting. Now these two processes are pending. Which process is a smaller one? P3 is a smaller one. So I will run P3. Why smaller? Just because SRTF says shortest process first. Now P3 we will run. Completed for one time unit. Yes. And after that at the end P1 we will run 4 plus 3, 7. Why 3? Remaining time is 3. Why there is no any preemption we checked here? Preemption occurs or happens when later on new process comes with a smaller burst time. In this SRTF, preemption happens when a smaller process arrives later. Late arriving process, but a smaller process. So a smaller process, when it arrives, current running process preempted. But at this point of time at 4, I was having only one process remaining, P1, and that was the only process. That was the only process. There is no any arriving process after that? No. So we will continue P1. P1 will not be preempted. Are you guys done with this? Now, based on SRTF only, I will see the completion time. Now, look at this. This is with practice you can understand, but at the first time you need to check. P1 executed here for some duration, but did not complete here. P1 is completing here at 7. So, completion time of P1 is not 1. Completion time of P1 is 7. Remember that in preemptive algorithms, a process may run sometime here, sometime here, sometime here like this. So just check the last timestamp when actually it is completing, fully completing. P1 at 7, P2 at 3 and P3 at 4. Turnaround time, completion time minus arrival time. Waiting time, turnaround time minus burst time, 3, 0 and 1. Average waiting time and turnaround time we can calculate. 7 plus 3, 9 plus 2, 11, or 7 plus 2, 4, 11 plus divided by 3 is 3.66667. Average waiting time is 4 by 3, which is 1.33. If you guys understood how did we solve this, then we can solve a question here. Yes, of course we can solve this one. Let's try. 6 processes are here. Let us try. Try this question. This is so easy, so good. Sir, what rank within how many digits would I need to get into GATE CSE 2028 so that you would give me a iPhone? Top 3 rank. If you are getting 1, 2 or 3, surely I'll give you an iPhone. Are you guys understanding how to solve this question? Okay, one more time I can help you guys how to solve such question. Time 0. I will check arrival time. Only one process P1 arrived. If only one process arrived, I don't have choice. I'll have to execute that only. So I will execute P1 process at first. Not for longer duration. I will execute P1 only till next process comes. Next process comes at 1. P2 comes at 1. So I will run P1 for one time only. Remaining time is 5 and at 1 P2 comes. Now when P2 comes at 1, P2 is also having remaining time 5. I had to change P1's remaining time always in the preemptive algorithms when I am running some process. Always remember this remaining time you need to check. Remaining time, remaining is 5. P2 arrives, its remaining time is also 5. Now both processes are equal burst time. Which process to run? As according to scheduling algorithm, if two processes are having equal burst time, then continue the early arrived process. Early arrived process is P1 only. I will continue it till 2. Remaining is 4. Why 2? Just because I have checked here at 2, another process P3 is also coming. A P3 is coming. Yes, P3 arrived with remaining time 1 and this P1 is remaining with 4. What happens? If P1 is remaining with 4, then I will see P3 which arrived now is having smaller burst time. Let's run P3. P3 will run for one duration till 3 and P3 completed. There is no any remaining time now for P3. But at 3, P4 arrived. P4 is having burst time 2. So P1 already remaining with 4 time. P2 remaining with 5 and P4 arrived with 2. 4, 5, 2. Minimum burst time is 2. I will continue with P4 now. P4 runs for one time unit till 4. Remaining, I'll have to update 1 and at time unit 4, P5 arrived. P5 arrived and it is having remaining time 1. If it is having remaining time 1, smallest burst time first, both are having equal burst time. So I'll go with the minimum arrival time. I will continue with P4. I will continue it till 5. P4 completes. At 5, P6 also arrived. Now remaining process P1, P2, P5 and P6. Among these, the smallest process is P5. I will execute P5. One duration till 6. Done. Now 4, 5, 4, 4, 4 are minimum burst time. If burst times are equal, I'll check the arrival times. Arrival time here is 0, smaller. So I will execute P1 first for 4 time till 10. Then P6 till 14 and then at the end P2 till 15. Oh, plus 5, right? 19. 11, 12, 13, 14, 15 plus 4, 19. Yes, 19. Completion time. P1 completes at 10. P1 executed here but actually completing at 10. P2 completing at 19, P3 completing at 3, P4 at 5, P5 at 6, and P6 at 14. Turnaround time, completion time minus arrival time. 10, 18, 1, 2, 2, and 9. Waiting time, turnaround time minus burst time, 4. 18 minus 5 is 13. 0, 0, 1, and 5. Is everything all right for all of you? Are you guys getting this? See, these are the things same to same for all algorithms. Only making a Gantt chart is important. Now, just because one process runs here also and here also, just because P1 preempted here and then executed here. So if one process runs multiple times, here the number of context switches are also more. So how many context switches? 1, 2, 3, 4, 5, and 6. 6 times. Look at here. P1 to P3, 1. P3 to P4, 2. Then 5, 3. Then 4. Then 5. Then 6. 6 times process switch happens. Number of context switches is equal to 5. Here in this example, how many context switch? In SJF, only 2 context switch. Look at this. 1 and 2. 3 process, 2 context switch always. If n number of processes are there, non-preemptive algorithms will have n minus 1 context switch. No any thought process, nothing. Always n minus 1. N times process run happens. Then n minus 1 times switching. 1 to 2, 2 to 3. Simply n minus 1. If 3 processes are there in SJF non-preemptive algorithm, 2 context switches, you don't have to even execute them. But here in preemptive, number of context switches can be more. So number of here context switches are how many? 3 in this case. 1, 2, and 3 in this SRTF. Okay, now one more question for you guys. This is also having some other concepts to understand. Let's go ahead with this. Solve it. Now this will test your different kind of understanding. Try this question. You should definitely try, otherwise you will not understand how exactly the questions are being solved. Try. Okay, I guess you guys are trying. If you guys are trying, let me know. Otherwise, I will try and explain you what exactly happening over here. Okay, P1 only arriving at time 0. So I'll have to start with P1 only. P1 will run till 1 duration time. 1 P2 arrives. Its remaining time is 8. P2 is smaller. Yes. So P1 preempted. P2 executes a smaller time 6. Here execution time 8 remaining. 6 is a smaller. New arriving process will preempt the current P1 process. P1 process preempted. Yes. And P2 runs now. P2 runs one time duration till 2, remaining time is 5, and at 2 P3 arrives. P3 arrives with execution time 4. Oh, it is smaller than P2's execution remaining time. So if it's smaller, then smaller process will preempt the P2 process. P3 runs next. P3 runs till 3, remaining time is 3, and now look at this, P4 arrives at 3, which is even smaller than 3. Smaller than this. So what happens? P4 arrives. P4 arrives till 4 and remaining time is 1. Now at 4 no any new process is coming. Next new process coming at 6. So we will continue with P4 and we will completely execute it till 5. Done. P4 completed? Yes. Now if P4 completed at 5, what all processes we are having left with? These 3 processes. Why? This P5 with minimum burst time 1 yet not arrived. It will arrive at 6. So if it will arrive at 6, what I will do at 5, I will choose the smallest among these 3. Smallest among these 3 is P3. P3 will run next till 1 time duration till 6. Why? Just because at 6 new process P5 is arriving. So it will remain with 2 time unit. Now, if P3 I have run for 1 time unit till 6, remaining time is 2. P5 arrive at 6 with burst time 1. Oh, its remaining time, current remaining time 2 of P3. P5 arrives with remaining time 1. 1 is smaller than 2. Let's execute P5. So P5 will execute first till 7. Now, arrival is not gonna happen. Let's execute the processes one by one in their order of burst time, smaller burst time. So smaller burst time, first P3 will run completely till 9. Then P2 will run 9 plus 5, 14. Then at the end P1 will run 14 plus 8, 22. Okay, let's fill up the values. P1 completion time 22. P2 completion time 14. P3 completion time 9. P4 completion time 5 and P5 completion time 7. Shivansh has written completion time, but Shivansh, P5 is arriving at 6. How can you execute P5 till 5 time unit? You tell me. Is it possible to execute a process which has not yet arrived? Before even it arrives, you have completed it. P5 arrives at 6. Its completion time cannot be lesser than its arrival time. No, never. Turnaround time. Okay, turnaround time is what? Completion time minus arrival time. 2, 7 minus 6, 1. Waiting time. Turnaround time minus burst time. 13, 7, 3, 0 and 0. How many context switches? 1, 2, 3, 4, 5, 6, 7 and 8 times context switches. Number of context switches will not be dependent on how many processes we are having. Context switches definitely minimum are 4, more than 4 possible, yes, but how many we don't know. Just because it is purely dependent on which process coming when, what is the burst time. So we cannot have any specific formula in preemptive algorithm that these many context switch can occur. In non-preemptive, yes, context switch for 3 processes, 2 context switch. For 6 processes, 5 context switch. Always yes, for non-preemptive algorithm, 5 processes, 4 context switches. Confirmed, yes, but in preemptive, we don't know. That's why we will have to calculate here. SRTF has exactly same characteristics as SJF. 2 differences. First, it is preemptive type algorithm. And second, it will provide the minimum average waiting time among all scheduling algorithms, including preemptive and non-preemptive both. If you include only non-preemptive algorithms, one process scenario given, which algorithm will provide minimum average waiting time? Answer is SJF. If you include preemptive only, minimum average waiting time given by SRTF. If you include preemptive, non-preemptive both, then too SRTF will give you minimum average waiting time and minimum average turnaround time also. In continuous run, better throughput means maximum number of processes you can execute within short duration of time. Disadvantages are exactly same. This will also having starvation. Bigger process may starve for CPU. It will not get the CPU. Practical implementation not possible just because burst time is not known in advance. So same to same, we have here the disadvantage and advantages. Only disadvantage SJF having more is it is not having preemption solved here. Other than that, same to same, advantage and disadvantage apart from the preemption. Okay. So I have decided to teach this much only. Reason being my health is not keeping well, but I did not want any kind of missed class from my end so that you guys can have some continuity. That's why I just came over here and taken this small class today. Tomorrow we will have a bigger one where we will study 3 different algorithms. Longest job first, which is just opposite of SJF. Then longest remaining time first, which is just opposite of SRTF, preemptive version. And then we will study the priority based algorithm. So these 3 algorithms we are going to discuss tomorrow. And then further round robin and some other algorithms we will discuss after that. Okay folks, thank you so much for joining for the day. Today we are done with this much only. Thank you. I hope you understand my situation. See you again tomorrow. Bye-bye.